MSM3. We're doing Unit 3, Lesson 5. We are talking about the distributive property. Often you need to do mental math, and we usually use some sort of shortcuts to do that. And one of the shortcuts that we use, your parents included, is the distributive property. So things that we can do mentally, instead of doing 7 times 108, we often do 7 times 100, and then we add in 7 times 8 and combine them. If you had something like 15 times 98, your parents will probably do 15 times 100 and then take away 15 times that extra 2. So 100 minus 2 is worth the same as 98. The last one, 9 times 999, no one does this in their head. They do 9 times 1,000, and then they take away the extra 9 times 1 because they bumped it up by 1. This is the distributive property. Now, the important thing you know about the distributive property is that it has to be what is called over addition or over subtraction. Inside the parentheses, there has to be addition or subtraction. So when we go to use this, there are some times when you'll see things that have multiplication, like when we did scientific notation. That was not the distributive property because it had multiplication inside the parentheses. So if we're going to use the distributive property for something like 6 times 28, I want to find an easier, more convenient way to represent 28. There's a couple options. I can think of it as 6 times 20 plus 8. That's one of them. 6 times 20 is 120, and 6 times 8 is 48, and then I add them together for 168. Another way to think of 28 is 30 minus 2. And sometimes we don't think of the subtraction ones, even though sometimes they can be easier. 6 times the 30 is 180, minus 6 times the 2, which is 12, and 180 take away 12 is also 168. Two different ways to do the same problem. Now this one, most people are going to see it as 1,000 plus 3. 12 times 1,000, or 12,000, plus 12 times 3, which is 36, and you get 12,036. That's pretty easy to do in your head by pulling it apart into 1,003. Now this one, let's say this was 6 groups of $13 each. I'm going to go to, let's say, a concert, and I've got 6 people, and we're each going to get the nacho platter. So 6 people each pay $13 for the nacho platter, and 6 people each pay $87 for the tickets. Well, instead of saying 6 people each paid $13 for the food and 6 people each paid $87 for the meal, we can add together the stuff that the 6 people each did. So if 6 people each paid 13 and 6 people each paid 87, we can say that 6 people paid, and we can combine the 13 and the 87, which is 100. And 6 times 100 is much easier to do than the 6 times the 13 and the 6 times 87. So you want to look for that. See if there is a way to make the problem easier, either by pulling numbers apart or by combining them if they're being multiplied by the same thing. So we're also going to look at algebra tiles. And when we look at algebra tiles, the small square is going to be worth 1. The long rectangle is going to be worth x. So if we used algebra tiles to represent x plus 3, we would use a single x tile, and we would use 3 what are called unit tiles. Use algebra tiles to represent 3x plus 2. So for this, we could do 1, 2, 3x plus 2. We could also do 1, 2, 3x plus 2. There's lots of different ways that you could assign it. But that is what we're looking for. How do we represent unit tiles and x tiles to stand for variables and numbers? Excuse me. Using the algebra tiles can really help explore the distributive property. So this one, if you look across the top, this is x long plus 2. If you look down the side, this is 1, 2, 3 tall. So this is 3 groups of x plus 2. So if you want to, I can highlight that, and you can say, here's an x plus 2. Here's an x plus 2. And here's another x plus 2. So that's one way of looking at 3 groups of x plus 2. Now, I could also choose to group it differently, and I could say there are 3 x tiles and there are 6 unit tiles. So I could also describe it as 3x plus 6. So if I distribute the 3 times the x, there's 3x. And if I distribute 3 times the 2, that's where the 6 comes from. You'll see me use these little rainbow arrows a lot. So on this first one, they did 3x times the 2 on the outside, and they did 4 times the 2 on the outside to get 6x plus 8. I'm going to do a whole bunch of these. The distributive property is something we will use for a long time. So simplifying the distributive property, I can multiply 6 by both of the terms inside over addition. So 6 times 5x is 30x, plus 6 times 10 is 60. I can distribute the 4 to both of the terms inside the parentheses over subtraction. 4 times 2x is 8x, minus 4 times 7 is 28. I can distribute the 3x to both terms inside the parentheses over addition. 3x times 2y. So I can multiply the 3 times 2, which is 6, and then I just put xy because I don't know what they're worth. And 3x times 9 is 27x. If I distribute the 7x times both of the pieces on the inside, 7x times 3 is 21x, minus 7x times 5y. 7 times 5 is 35, and the x times the y is just xy. This one, I've got 3 terms inside, and I'm going to distribute the 6 to each of those. 6 times 4x is 24x. 6 times 7y over addition, 42y. And 6 times 10 is 60. Now, it gets a little trickier when you have the variables. 3a squared times 10a squared. Since it's multiplication, I do 3 times 10, which is 30. A squared times a squared, I add my exponents together and get a to the 4th. 3a squared times 3a, 3 times 3 is 9. A squared times a, add my exponents together, a to the 3rd. Last but not least, we've got a mix of variables. If I don't know what they're worth, I just sort of write them next to each other like, I'd like to multiply these, but I can't. 2a times 3x is going to be 6ax. 2a times y is going to be and 2ay. 2a times 10z, 2 times 10 is 20az. Cannot go any further than that because I don't know how much the variables are worth. Last but not least, you may be asked to do sort of the inverse of the distributive property or to undo the multiplying. And this requires that you have a good understanding of your multiplication facts. So we're looking for factors. 4x plus 8. What do 4x and 8 have in common? Well, they can both be divided by 4. So what we're really doing here is we're saying, I'm going to divide everything by 4. That 4 becomes the number on the outside of the parentheses. You're taking the 4 out. 4x divided by 4, 4 divided by 4 is 1, so I only have x left over. Whatever you have remaining when you divide by the 4, those are the terms that go inside the parentheses. Plus, 8 divided by 4 is 2. So in your head, you can always check these and say, what is 4 times x? 4x. What is 4 times 2? That's where my plus 8 came from. I do suggest double checking after you think you've got the answer. So 30x minus 20. 30 and 20 are both divisible by 10. So the 10 is the number that I'm dividing by, or I'm sort of removing it from the 30x and from the 20. 30x divided by 10, 30 divided by 10 is 3, and I still have the x, minus 20 divided by 10 is 2. I can double check my answer. 10 times 3 is 30x. 10 times 2 would be minus the 20. Here, I now have a variable in common. So not only can I divide by the 8, I can also divide by the x because both terms have an x. So 8x would go on the outside of the parentheses. 24 divided by 8 is 3. X divided by x came on the outside, and then I still have a y left over. Plus 8x divided by 8x, it goes in one time, or 8 divided by 8 is 1, x divided by x is 1. I have 1 left. Now, how do I check that? 8x times 3y is 24 with the xy. 8x times 1 is just 8x. All right, what do they have in common? 6 and 3 can both be divided by 3, and both terms have a b. 6 divided by 3, so I put the 3b out here. 6 divided by 3 is 2. The b's will cancel each other, or b divided by b is 1, so I just have an a left, minus 3b divided by 3b is 1. It goes in exactly once. Now, these two do not have a coefficient in common. There's no number out here in front of the x squared. They do, however, have an x in common. So if I divide both of them by x, Think of x squared divided by x. If I subtract my exponents, I still have an x left over. X times x will give me x squared. And 3x divided by x just leaves me with the 3 because the x divided by x will cancel. So like I said before, distributive property not going away anytime soon. We will spend a lot of time using and reviewing distributive property. And remember, it always has to be over addition or subtraction in the parentheses.